So here at the end of the packet, we want to discuss how to deal with all of these different levels of ionic nomenclature combined. And so, of course, the goal here is to be able to look at formula or name for cation or anion and quickly recognize the formula. And again, I'm going to start with anions because we always know their charge. And so here in my first formula, I have SO4 as my polyatomic. The 2 outside the parentheses came from the charge. Here inside the parentheses I have ClO3. The understood 1 on chromium came from its charge. Here I have sulfur. The 2 on vanadium came from its charge. Here I have CO3, carbonate. And again, the 2 on aluminum here came from its charge. And so I can quickly check those. And yeah, each of those is the case. So I don't have any situations here where I'm going to have to worry about reduction of the ratio or scaling or a one-to-one situation. Now, from the name, right, I want to look at the ending. IDE means that it's monatomic, so I need to know what group it's in. Iodine's a halogen in group 7A, so I know I'm dealing with I-. Here I have phosphate that tells me it's a polyatomic. For now, you can look up the formula, PO4 3-. Nitride versus nitrate, right? This is monatomic. And so there I need to know that it's in group 5A. And so I know that I'm just dealing with nitrogen as 3-. Here it ends at 8, so that's poly, and the formula for nitrate is NO3 - 1. And obviously if I have the name, I don't have to worry about the charge because I am writing down the anion formula from the name. Now, if we look at cations, because I've already done my due diligence with the anions, I can just uncross my subscripts. So here I have NH4, and the understood 1 on sulfate means that it's +1. Here I have chromium, and the 6 outside the parentheses means that that's the charge on my chromium. My vanadium is +3 due to the subscript on my sulfur. And this 3 outside of my parentheses means my aluminum is 3+. And again, those are all going to be my correct charges. Now, when I have the name, right, if there's no Roman numeral, that means it's type 1. I need to know what group it's in. Calcium's in group 2A, so that's 2+. Nickel 2 with that Roman numeral, that's going to tell me the charge. So here I'm dealing with Ni 2+. Chromium IV, the Roman numeral tells me the charge. It's type 2. IV is 4+. And again, strontium, just like calcium, is in group 2A, so it's also 2+. And then again, once I have my ions, everything else is straightforward, right? To get my formulas now, I just cross charges if I'm going this way. And so I would have Ca I2, Ni3, PO4 in parentheses 2, Cr3, N4, and Sr NO3 2. And then to get from ions to name, right, I'm going to start by naming my cation. And so NH4+ is my only polyatomic. That's the ammonium ion. Here I have chromium, which again we've seen multiple times, is in the D block, so I have to use a Roman numeral and say chromium 6 or Vi. Same thing with vanadium. It's one of the most common of the transition metals. So here it's +3, so I have to go I. And then aluminum is in group 3A, so no Roman numeral necessary, it's just aluminum. And then to name the anion, again, if it's polyatomic like SO4 2-, it's going to end in 8, so this is sulfate. Here I have chlorate. If it's just monatomic, it's going to end in ide, so this would be sulfide. And finally, I have carbonate. I'm just going to come in here and erase some of my work just so we can kind of just see the answers here. And so again, this is what I would expect you to be able to do. This is what I'm asking you to do at the bottom of homework 4, but also you should be able to do on the exam. So this was a long packet. You can see why we spent 2 weeks on this. Thank you ever so much for your time.